Let's transform some statistics and distributions. What I have shown right here are the commute times that it takes people to get to work. These are 60 individuals here, and how long it takes them to get to work. Truly, how I got these numbers is I just randomly generated them. But let's go ahead and get started with the most important thing. We need to find all of the statistics for this distribution. So that's the mean, standard deviation. We're going to find the minimum, quartile 1, quartile 2, all the way through. Actually, we're going to do all these quartiles. And I want to get the IQR. Okay. So if you want to type in this data to try it on your own, you can either use your TI Inspire or your TI-80 calculator. It may take you a moment, so if you want to pause the video and get that typed in, go for it. Now, once you have it typed in, so I'm using the TI Inspire. I don't have the emulator for the TI-80. We're going to go ahead and run our statistics and do one variable statistics. And I want to name my list commute time. This would be L1 if you're using the 80 series. But let's go ahead and get these values. So I've got 22.8, 14. I'm going to round to one place on all these. So 22.8, 14.6 for mean and standard deviation. 8, 6. Go down further. And let's find the other values we need. We need the minimum, which is 1 minute, which, you know, I said these are random numbers. So 1 minute commute time. I mean, they literally like live near their work, if that's what they do. 1, 10.5, and 19. 5, 8, 19. Yep, 37. Maximum here is 45. And then I want to get my IQR, so that is Q3 minus Q1. I'll just write that in here. And that is going to equal, so let's 37, take away 5, so 26.5. Okay, now that is just typical data statistics. We haven't actually done any transforming or anything like that. A lot of times in questions that you'll see, they are going to have a context. So for instance, one that I'll use here, let's say that for these people to get to work, there's some sort of construction going on when they get in their car. Now, just try to use your imagination. Obviously, the person that takes 1 minute, they could probably walk instead. But let's imagine or consider that there's some sort of construction, and we're going to add 5 minutes to all these times. So we're going to say, consider that it takes 5 extra minutes to commute. Okay, so we need to think about what is that actually going to do to our distribution, to the statistics and to the distribution itself. Well, first thing I want to do is I actually want to look at this distribution. Here is our histogram right here of this distribution. Okay, so I'm going to just copy that in so we have an image of what it looks like. And we're going to put this over here. Paste it. Here's what the distribution actually looks like for this data. Okay, and the mean, we see all the statistics, the mean commute time, it's sort of right here in the center, but that's what we have here. Okay, so what is not only going to happen to the statistics over here, if I add 5 to each commute time, what's going to happen to the actual distribution itself? Well, let me show you a quick way that I want to add 5 to all of my values. So over here, I'm going to actually use the word plus, or I'm going to put 5, okay, because I'm going to add 5. Now, on the Inspire and really any spreadsheet, I believe you can even do this with the 80 series TIs. You'll just have to look it up. But I can actually type in the word commute. Spelled it wrong. you'll know that you did it right when it becomes bold like this down here on the bottom. And I just want to add 5. So 5 minutes get added to, you can see they're added 5 to every single time. And we'll look at what that does to the distribution, but I want to go ahead and calculate the statistics for this. So we're going to do another one variable statistic and just change that list. So 5. And here we are. So the mean is 27.8. Deviation 14.5, and you see that all these here, some of them have changed, some of them have not, and that's really what we're going to be talking about is what's changed and what hasn't. Well, the the mean for this is now 27.8. Go back to it. Let me go back up. There it is, 27.8, and I'm going to go ahead and fill all these out. The standard deviation, that actually did not change. Look at that. The minimum, not 1 anymore, sorry. It actually went up by 5 because we said we added 5 to every time. So 6, Q1 became 15.5, Q2 became 24. 42, and then the maximum 50. Okay. IQR, if we calculate this, let's do, we want 42 take away 15.5. You'll notice that it didn't change either. Okay, so those are the only 2 things that didn't change, were the standard deviation and the IQR. Now, if you're in a stats class, it's probably been described to you that mean and median and a lot of these other 5-number summary values, they are measures of center and really position. But then standard deviation and IQR are going to be measures of spread. So what we're seeing here is that it doesn't really change the spread of this distribution. I'm going to show that with a picture. So right here. Look at these 2 graphs. This is the original is right here. The original commute time is up top, and then the bottom is when I add 5. Okay, there's the original, and you can see a lot about this. It's the same exact shape. Look at the shape of the top and the bottom. They're the same, and when I put them on the same scale from 0 to 60, all you see that's happened is it's shifted. So the actual spreadness of this data, it didn't change at all. Every point still is the same distance from the mean, and the quartiles, all of them shifted 5, so they're still spread out, so the IQR wouldn't change either. So let's put that in here and go ahead and get our graph put in here. So now we have that, and now we see that just from adding, only addition, so that's the operation here, addition, just changes everything except the measures of spread, and we see that on the graph. So I'm going to write down a rule, adding, subtracting, because this would also work if we subtracted 5 minutes, a value from a distribution changes the mean. I'm going to say X bar for this. The X bar and the 5-number summary. I'm going to use that 5-number summary. By adding or subtracting say that value from those statistics. And that's what we're seeing here. Everything went up by 5 except the standard deviation, and the IQR. And just in general, this adding, subtracting, I'm going to put addition, abbreviate it, subtraction, only affects measures of center or position. Measures of center, really, and I'll just leave it at that. Okay, so that's quite a lot there as far as a rule goes. But if you want to get that, pause the video, copy that down into any notes that you have. This is really what will be assessed, your understanding of this. Okay, and you can look back at our chart to show that everything went up by 5 except the standard deviation. Okay, now we have another thing to consider. Here's a scenario. Let's say that I accidentally recorded these times in minutes, and for whatever reason, I wanted them actually to be how long it takes them in hours. So consider the data in hours instead of minutes. Okay, so hopefully you're already thinking about what kind of transformation we would be doing. Last time we said there was construction and we had to add time. Now we're not going to be adding anything here. We got to convert minutes into hours. And so since there's 60 minutes an hour, the operation will be divide by 60. So that's what we're going to be doing to the data. Now, how will this affect it? That's what we need to know. So we're going to write out all these statistics again, and we have to, of course, perform the transformation in the calculator or spreadsheet, whatever you're using to manipulate the data or change it. But I'm going to go ahead and write this out, and you can write this down if you are taking notes along with me here. And then we're going to get this transformed. So back to the Inspire. Let's go back to the very first page right here. Now I want to, up top, I want to make a column for hours. So I'm going to put HRS. Okay, that seems good. Now we want to do the same thing we did for commute being added with 5, except this time commute. We are going to take it and divide it by 60. Now, if you just hit enter, it's going to give you a bunch of fractions. I'll show you that. Okay, and I don't really want fractions. It's not very useful, and it's not easy to read. So if you want decimals, you can just type a decimal here, and it will auto-calculate those to decimals, which is a lot better. Let's go ahead and get our statistics that we want for this. So statistics, let's do that. And we're going to do this. Here are all of the values we need. Okay, so starting with the mean, 0.38, and the standard deviation of 0.24. I will write 2 places this time, so 0.38 and 4. Let's get all of the rest of the values. I know that this one's going to be 1/60th, I believe, but as a decimal, there's the minimum. I'm going to go 0.02 for that one. 0.18, so 0.02, 0.18. Next one is 0.32, 0.62. Maximum, and I'll have to get the IQR here in a second. Maximum is 0.75, and then I'll calculate this IQR. So 0.7 R, we're going to do 2, take away 0.18. So 0.44 is going to be the IQR. Now, compare this to where we started. Not here. This was the other transformation we did. I'm talking about these values. And we have to look at what actually changed. Remember when we just did addition, the spread didn't change, but look at our standard deviation here, 14.6, stay the same here, but when we go over here, it too changed. Okay, and as a matter of fact, all of these values actually have changed in some way, shape, or form. Let's look at the distribution as well. So let me scroll through my tabs. Here are the distributions. This is the regular one, the commute time on a scale of, I believe it's 0 to 60 like I had it. Let me just make sure. Oops, hold on. I need to change this to 0 and this to okay. So there's that one. Now you'll notice the scale on this one. It's small decimals. So if I change this scale, you can sort of predict what's going to happen here. Here we go. Once I hit enter, you're going to see that this bottom one nearly vanishes. Look at this. It's over here in the corner. And what's happened is this whole thing has been sort of compressed into a small part. Now, the overall shape of it still looks like this. As you see, if I undo that, it still generally looks the same. Okay, and that's correct. It should. But as soon as I convert it back to the same scale, it's super squished. Okay, and that's from dividing. Now, let's say I wanted this in seconds. Well, it would expand, and this one would look smaller. But that's what's happening with this. So the spread changes, and so do all of the actual statistics. So let me copy down this distribution. Get a good picture of it. Let's throw it into the video. Oh, I accidentally marked it. This. Okay. And let's put it right here. Okay. There's our distribution. You can see how it's changed. And let's write down our final rule. And hopefully this has helped you in some way if you're not in one of my own stats classes, which is why I made the video. But if you're in your own and you needed a better explanation, hopefully this helps you a little bit. But let's write down the rule for multiplication. I'm going to say multiplying and dividing. Multiplying and dividing a distribution, abbreviate, by a value affects all statistics. And those statistics will be multiplied or divided by that value. And then for this, if this is a question, it's important. Multiplying, dividing, I'm going to abbreviate, multiplication, division affects both center and spread. Okay, and just to confirm this, if I go back over to, let's go back over here. Let's take our mean. I'm just going to do two of these. So I want 22.8 divided by 60. I got 0.38. So if we go back over here, that's what we see for the mean right here. Let's try the standard deviation. The standard deviation was 14.6. Divide it by 60. 0.243. Go back over here. There it is, 0.24. Okay, so, and if I could do this for all of these, they are all divided by 60. Okay, so multiplication, division, if you're doing multiplying or dividing by a particular number, it changes all of those. All right, hope this video is helpful and will help you on your next test or any assignment that you have.